Hey guys, so today in class we were playing a spinner game where you would spin a spinner and wherever it landed, that's like you had a certain percent of the chance that it would land there because it was a certain percent of the circle. And then if the spinner landed in a certain region, then you had a payout. So in this setup right now I've got region A, B, C, and D. Region A is 50% of my circle, B is 10%, C is 5%, and D is 35%. And if I were to go ahead and add money amounts on this, let's say I made the 50% be one worth $1. Every time I landed on it, I got $1. The 35% I made $3. The 5% would pay out, let's say, $20, and the 10% would pay out $5. Okay. Expected value is looking at the situation mathematically and figuring out how much money you would expect to make if you were to repeat this process over and over and over again. And so the way that you do that, for instance, if I wanted to find out the expectation, like if I were to do 10 spins and see what I would expect to have happen, for region A, since I expect it to happen 50% of the time because it's 50% of the circle, I would say 50% or 0.5 times the number of spins is 5. And so what that means is half of my spins, half of 10 or 5, I would expect to land on this guy. So I would expect 5 spins to land on A. Now if that happens, if 5 of the spins land on A, then I get $1 for each of those. So I would do 5 spins times $1, and my expected value for this would be $5. For region B, I would take 10% because region B is 10%, so 0.10 times 10. Well, 10% of 10 is 1. So I expect 1 of my spins out of 10 to land on region B, and that 1 spin, when it does land there, is going to pay me out $5. And so its expected value is $5 also. Now here, it lands on region A more often, but you get paid less. Here, it lands on region B less often, but you get paid more. And they end up being the same expected value. Now, on region C, if I were to look there, I only expect it to land there 5% of the time, or 0.05 times 10, which means I don't even expect it to land once. 5% of 10, if I did it on my calculator, I could do 0.05 times 10. I only expect it to land there half of a time. 0.5 of a time, which I know isn't realistic for 10 spins, but it would be for more. And that makes sense, right? Because half of 10% is 5%, so it's half of the number of spins. But if it were to land on region C, then I would make $20. And so even though C is less likely, the payout is high enough that it makes the expected value, half of 20 is $10. Okay. And then for region D, I expect it to happen 35% of the time. So 35% of 10 spins is 3.5 spins. And when that happens, I would expect to make $3. And so in this situation, 3.5 times 3 would give me 10.5. What expected value does for us mathematically is it allows us to see which situation would be our best bet. So if we were playing that spinner game again, if you calculated the expected value, it would tell you that you should be betting your money on region D because it's the best combination of size, it's one of the bigger areas, and payout. Okay, so it gives us 10.5. Now just looking at the size of the region doesn't always do us very good, and just looking at the payout doesn't always work for us. You have to see the best combination of the region, the percentage of the region, and the payout. So in general, this is the last thing for your notes. Expected value equals your probability, that's the percentage that we are using, so like 35% or 5% or 10%, times your number of trials, right? So the number of trials was like 10 spins in our case. And then you're also going to multiply it times the payout. So that's where we get the like $3 payout or $20 payout. So if you're trying to figure out how much is something's going to pay you over a number of trials, you do the probability of it happening times the number of trials times the payout. All right, make sure you have these in your notes and bring them to class tomorrow. Thanks, guys.